In this notebook, I did for experiment 5, which is multi-layer perceptron using PyTorch. So my data set, which is digits data set, which contains images of handwritten digits from 0 to 9. So each image is 8 cross 8 pixels, which means each image has 64 numerical pixel values. So the goal of the experiment is to build a multi-layer perceptron neural network to classify handwritten digits. So the first step, the digits dataset is loaded from the sklearn.datasets.module. The dataset contains input features, which is the pixel values of the images, and the target variable, which is the digit 0 to 9. So I have imported over here, and it is having 65 rows and 7 columns. So for the second question, I choose independent variable, which is x, and dependent variable y. The input features of the data set is the pixel value of the images, and the target variable is the digital label, which is 0 to 9. The goal of this model is to classify image based on these pixel values. So here is the independent variable x and the dependent variable y is shown. And third question have standardized input variables using standard scaler. Different input features may have different scales. So standardization converts all features to a common scale with the mean is equal to 0 and standard deviation is equal to 1. So this improves the neural network performance by ensuring that no feature dominates due to larger values. So in the output, you can see mean after scaling and the standard deviation after scaling. And for the fourth question, I have split the data into training and testing. So training, which is having 80%, and testing, which is having 20%. So training data is used to train the neural network and update the weights, and testing is used to evaluate the performance of the trained model. So this ensures the model is tested on the unseen data. So the training set size and testing set size is shown in the output. And for the fifth, I have converted the input data into PyTorch tensors. So PyTorch models usually they require data in the form of tensors. So a tensor, which is a multi-dimensional array similar to a NumPy array, but only optimized for deep learning operations. Therefore, the training and the testing data are converted into PyTorch tensors. You can see the features tensor and target tensors over here. And for the sixth question, I have defined the MLP model layers configuration. So MLP is a neural network consisting of multiple layers. So the hidden layer structures for this data set is 128 neurons, 64 neurons, 32 neurons, and 16 neurons. So this model contains input layer, hidden layers, and output layer. So activation functions such as rectified in linear unit are used to introduce non-linearity to the model. So I have did that so this is the output. And for the seventh question, I have trained the model using backpropagation and gradient descent. So during training, the input data passes through the neural network. So the model predicts the output. The predicted output is compared with the actual output. So the error is calculated using a loss function. So the error is propagated backward through the network. This process is called backpropagation. So the weights are updated using the gradient descent, which reduces the error over time. And for the eighth, I have plotted the training curve. During training, the error value is recorded at each iteration. So a graph is plotted with x-axis having number of iterations and y-axis having training error. As the model learns, the training error gradually decreases. This shows the neural network is improving its predictions. And for the ninth, I have tested the model. After training is completed, the model is tested using the test data set. The trained neural network predicts the digital class for each image in the test set. This step evaluates how well the model generates the new data. So this is the predicted digits and the actual digits are shown here. And for the 10th, which is last question, I have displayed the confusion matrix and the performance for the model. A confusion matrix is used to evaluate the classification performance. It shows correct predictions, incorrect prediction, and how each class is classified. The performance analysis report is over here. I have calculated accuracy and precision and recall an F1 score. Thank you.